So any questions about these four things that you're going to mess with in decimals? Okay, again, we're going to change the C term. Let me write that down again. I erased it.
Okay. Wait, but what do we start with? It's negative.
X squared. Okay, again, you're going to start by messing with your C term. That's number one. Okay? Then, we're never going to mess with the B term today. Then you're going to mess with the A term. You're going to make it bigger and bigger and explain what it does to your parabola. Then you're going to make that A term negative and explain what it does to your parabola. Then you're going to make it a number between -1 and 1 and explain what it does to your parabola. So you're looking for these general trends. And we'll put all those general trends together. We'll make some, like a rule together, some general ideas. Let me get out of this and show you in decimals. I'll give you some advice for getting started here. You're going to start with the base. Y equals x. Shift 6 will get you to your exponent squared. That's base. I would leave this on there to compare to. But it's not always fun to type over and over, so I'm going to copy. And I'm just going to paste a bunch of these on here. And then if you don't want to see it, you can just click these colors. Okay, so for example, for A, it wants us to add something to it. So what am I going to add? What's something to add to it to test? +7.
9.
I can't see that, so I'm going to zoom. Okay, so +7, it's up there. Let's subtract something. Subtract 7, okay. I don't see it.
You wrote =7.
My bad. Oh, and then I got to click this to, okay. And let's try +2. And light it up. Okay, so then you should be able to make a general rule of what's happening to your parabola when you change the C term. You're going to jot that down for number 1, and so on. Then you can choose to leave those on there. If you don't want to see them, just click these.
It's kind of like an onion.
And then you're going to mess with other things, okay? I'm going to put the things I want you to mess with up there. Good mess with, right? You're going to try to generalize 4 different little rules. All right, let's get you back to what you're going to work on here. All right, I think 5 to 10 minutes range, we could probably get her done, all right? So let's start looking at changing these things on decimals. So I think we were good when I was showing you how to be efficient. When we changed that C term, or that constant term at the end, what happened to my graph? How did it change?
The y-intercept.
The y-intercept changed, yep. But in the vertex, the vertex goes up and down. So all this did was, it's the same parabola. You guys see in the same parabola? It shifted it up or down based on if we changed that C term. The C term is the y-intercept. We also call it the constant. Yeah.
So you're saying it's basically the same line, just at different points in...
It's not a line now, but yeah, same exact graph. We shifted it up and down. That's the only change. Okay. So the next thing you did was you messed with the leading coefficient. And you made it bigger. Like 2, 5, let's do 2, 5, 10. And I'm keeping the original on there. So there's 2. What do you notice as we get a larger A term?
Slimmer.
It looks slimmer, but it's actually increasing quicker then. Yeah, that's why it's narrower. So you could use that terminology. As you get the larger A term or larger leading coefficient, it's getting more and more narrow. We're all good for number 2?
Yeah.
Okay. Number 3 said do the same thing, but negative. Look what happens when we when we do negative. It's the same exact parabola, but it's going down instead of up. It's negative. And the reason for that is when you're doing the order of operations, what do you have to do first? Do you multiply first or do the square first? So do the square first, then when you multiply by the negative, all your answers are going to then be negative. Yes. Okay, cool. Yeah, Anna.
So the x squared, what's the terminology for that again?
That's the quadratic term.
Okay.
And that value in front we will call the A term, or leading coefficient. Willa.
The A term, if you put it at negative, the line flips down.
It flips. It's the same exact thing, same exact width of the positive, but it flips down. And then the last thing, we're going to look at fraction or decimal leading coefficients. So let's say 1/2 compared to... So what'd you notice happened when we went to the 1/2?
Getting wider.
Wider, it goes up slower. So let's try, what's something smaller than a half to try?
0.20.
0.22, even wider. And as you go to 0, what do you think is going to happen at 0?
Straight line.
Straight line, because 0 times the quadratic term gets rid of the quadratic term. That would be a line. And then as you go negative, really little negative, let's say negative 1/2, it starts going the other way. You can see the progression. Huge leading coefficient of A, really narrow, smaller, smaller, smaller to 0 flat, then negative. It starts curving the other way. You can kind of imagine that. Yeah, Emma.
So when the quadratic term is a negative, it is almost like a reverse.
Yeah, it's the same as the positive because the x squared happens first. Then when you multiply by the negative, everything becomes
But
negative.
if the constant term is negative, that just means it can still
It just slides down. Yeah,
Okay.
because you're just adding or subtracting something at the end in the order of operations. Cool. So we've got those general ideas down. You are going to validate these general ideas with this table. I have these tables for you to fill in, okay? So we're going to fill out this table real quick, like x squared plus 10. I'm just going to add 10 to everything. And x squared minus 3, I'm going to just subtract 3 from everything. Negative 4. I got negative 2.
Yeah, I got negative.
Okay. That sounds like a great mistake, my man.
I was in the wrong.
Okay, so do you guys, it shifts it up and down, right? Are you guys seeing that? Just like we saw in decimals. And which term are we messing with, A, B, or C? This up here is messing with the C term or the constant. Okay, down here, we're multiplying x squared. So 9 times 2, 4 times 2, times 2, times 2, times 2, times 2, times 2. Down here, we're going to go half. So 4.5, 2, 0.5, 0, 0.5, 2, 4.5. And down here, we're multiplying by negative 2. Negative 18, negative 8, negative 2, 0, negative 2, negative 8, negative 18. So, what term are we messing with down there? A, also known as our leading coefficient. Okay. So, how is this changing things? Is it just shifting it up and down?
No.
In fact, it's not shifting it up and down at all. Look at this. It's narrower or wider, right? Look up here. We know it's shifted up and down. Check out right here. It was changing. Okay. So again, I like to think of it, the general way I like to think of it is, the bigger the leading coefficient, the narrower it is, until it gets wider and wider and wider until it's flat. And it's wide on the negatives until it's this huge negative. That's how I like to think. That's kind of like my imagery. And then the C term just moves the whole thing up or down. Next up, we have a card sort. I will give each group a stack of cards. You need to match cards. You will have a graph. You need to match these 3 things together. A graph, a standard form equation, and a factored form equation. So graph, standard, factored. Each group is going to have 3 things in it. You're going to have 4 groups. You just go sort it out. On the back of your notes, you will see a place to write what your functions are and do a sketch of the graph. Let's go. So everybody good with, we got our x-intercepts here. Negative 1, 1. Y-intercept here. All right. What did I do with that card? There it is. All right. Next card. Okay. So checking this one out. What intercepts am I looking for? Looking for an x-intercept of 2. Only one x-intercept this time. And I'm looking for a y-intercept of 4. Well, Bob, that's good to think about. Like, why is there only one? I know that this one gives me my x-intercept, right? Because this one is this. This give me 2 different x-intercepts? No, 2 or 2. It's just 2. So here's my first one. That's really good for my x-intercept. So now I have to find a y-intercept that matches it. I need a y-intercept of 4. And there's 2 different ones that have a y-intercept of 4, right? So what I would do is distribute here to see what I get. That gives me x squared minus 2x plus 4. So it's the negative 4x version in your card sort. This would be our standard form. Be careful, because did you guys notice there's another standard form with the y-intercept of 4? Yeah. So again, what I did is I changed my factored form to standard form. We did that our last quiz to find out which one I needed, because there was no other tell. All right, we're good? Here we go. So this one, we're going to look for x-intercepts of 4 and 1 and a y-intercept of 4. So as I look, I might go standard form because there's only one more standard form with a y-intercept of 4, correct? So I know that has to be my standard form. So then I'm going to look for my factored form that has intercepts of 1 and 4.
Why is there a 5?
I can show you why. So if you were to distribute this, here is a negative 4x right here. You seen that one? And here's a negative x. So negative 4x and negative x is negative 5x.
Okay.
Yeah. All right. I mean, there's only one more, right? So you know what matches. But let's get it in there with the reasoning. Okay, so this one. Uh-oh. I just lost my picture. Where'd it go? There it is. Okay. On this one, I'm looking for a y-intercept of 0 and a y-intercept of 4. So x-intercept. So I'm seeing this one for x-intercepts. Here's my 0, here's my 4. And then the one that gives me a y-intercept of 0 is actually this one. And you might be thinking, where's the 0? It's right there. Right? Anything plus 0 is just that thing.
I don't see a 0.
Exactly.
There's nothing.
You don't, if you add 0, it's the same thing. So again, the big generalization is factored for x-intercept is better. Standard for y-intercept is a little better, a little easier. It's right there in the factored form too. You just have to multiply.
So
All right.
is there a way to write like y?
We're gonna blast this lesson summary together just because it's actually kind of nice. So this one right here has to be which of the options?
The negative 1.
The negative one. There's only one negative one. Okay. And then how could we generalize? Like, what rule would we use to decide what the rest are, Micah?
We can generalize the A factor.
Yep,
whether
the A term.
Bigger or smaller.
Yeah, so wider, because it's getting bigger slower. The wider is the smaller one. So wider, middle, narrowest. Good? All right, homework stop basket. Let's go.